You probably know about the 208 wild leg, the high leg, the hot leg, the stinger, and there's probably a couple other names for it as well. But do you actually know how and why you get 208 volts? Let's get into it. You might have seen vectoring in the Sandbox lab in my Transformer app, and I know it looks complicated, but vectors are honestly the easiest way to understand what's visually going on with the voltage math. And don't worry, I'm going to break it down right now. So let's forget about the primary wiring and dive straight into a closed delta secondary. 3 pots wired corner to corner into a triangle. You can see each pot's coil above and below, and each corner of the triangle is just the wiring between 2 transformers. Each pot has 2 coils rated at 120 volts each, or 240 volts across both in series. I color coordinated these images, so go ahead and pause here and see how everything relates. Where we put the ground reference directly influences where our wild leg would be. When we ground an X2, we're giving the 2 coils attached to it 120 volts, and the wild leg is created at the corner opposite the ground reference. Now the distance between 2 corners is just the voltage between them, so the wild leg voltage is actually just the height of this triangle. It's the distance from the ground reference up to the opposite corner. So let's calculate the height. The formula is the square root of 3 divided by 2 times the length of one side, which is 240. But that's a little confusing, so we can simplify it down to 1.73, which is the square root of 3, times half a side, or 1 coil rating. 1.73 times 120 is 208. And that's the wild leg. It sits the delta's height away from the neutral reference. Ground a different X2, and the wild leg jumps to that opposite corner. And we've made it this far into the delta secondary, so we might as well button it all up. Whatever pot you ground becomes your lighting pot. It carries the lighting load, and the bank's secondary neutral reference on top of it share the 3-phase load. That's why the lighting pot is usually larger with a higher kVA rating. It's doing more. The other 2 transformers are the power pots, and they carry the 3-phase load. So when you swap a delta secondary out, that wild leg's got to land back on the same corner. If you flop where the wild leg lands on the customer service, you could burn up all kinds of stuff or start a fire. Now you know more than just the number of the wild leg. Now you know how and why it happens. I'm the JL who created the Transformer Lab app. Go check it out. Stay safe, boys.